それではお時間になりましたので、セッションを始めたいと思います。フローリアン様によるアシンクロナス PHP with ReactPHP です。よろしくお願いいたします。
Thank you very much. Hello, everyone, and welcome to Asynchronous PHP. With me, my name is Florian. I'm working as a software engineer at Datadog in the profiling team, where I'm building a continuous profiler for the PHP language. I'm also a contributor to open source. That's mainly stuff like GraphQLite and PHP Unit. And lately, it's also the PHP source documentation and the PHP source code repository itself. And earlier this year, I became the co-maintainer of xparallel, which is an extension that allows you to do multi-threading in PHP. And I'm doing all this, although I'm married with 5 children. Okay, so around about 10 years ago, I was working at an e-commerce retailer. And at this e-commerce retailer, we were selling stuff to people. People could order online. And once we had someone from customer care department reaching out to us that the customers are waiting too long at the checkout. So by checkout, they mean hitting the buy now button, like you have everything set up. You have the items in the basket, you have the payment options set, you set your delivery invoice address, everything is set up and done. And you're at this last page and you hit the final buy now button and you wait for the order confirmation page. So we wanted to know what too long actually is. So we added a tracking, just like an easy logging that we, at the end of this checkout process, we wrote the number of seconds it took for the request to be processed just to a file. So we could have a look into this file and could see what was going on there. Then the next day, we checked out this file, this documentation, this log file, and we found that most of the customers were waiting 2 to 3 seconds. We had customers waiting 5 seconds, some waiting 10 seconds for the checkout page to show up. And we even had one winner who was waiting 20 seconds for the page to show up. Also, what we did is we logged with the time to first byte, we also logged the order number so that we could check the order, what did people actually buy. And we found out there was a correlation, and the correlation was that people buying more items waited longer in the checkout. And that's only the server-side stuff. Additionally to that comes the client-side tracking, client-side JavaScript that people are loading on the checkout page. Okay, so 20 seconds is a no-go, even 10 seconds, I would say even 5 seconds waiting is a no-go. So we didn't want to have our customers waiting, so we wanted to check what is actually going on in the checkout. And the first thing that's going on, the, let's say, obvious, is we need to store the order in our persistence. In that case, it was a database. And we need to modify the stock so that other people cannot buy whatever you just bought. That's so far so obvious. The next thing that we would find is that we were sending tracking data to services. So there's a lot of client-side tracking where you just put in JavaScript snippets and it would magically send tracking requests to some marketing services. In this case, there was a server-side tracking for our catalog service. So when people go on the shop and they see a list of articles, this list is not sorted randomized, but it's sorted by behavior of the other customers in the shop system. And in order to do that, this service needs tracking data of what people actually buy. So this was one of the services. The other thing that we were doing, we were sending out order confirmation emails to customers. One thing that we found out about this is that we were sending it via SMTP, which was horribly slow at this point in time, mainly because due to a misconfiguration in the SMTP server we were talking to, that meant when we send the initial SMTP hello command to the SMTP server, it waited for a second until it gives us a response, which means that the PHP script is waiting, and that means that the customer in front of his device is waiting for the script. And that was one problem. The other problem was we were not only sending out one order confirmation email, but 2 order confirmation emails. The second one was pretty funny because the second order confirmation email was sent to the shop owner, which was us, but we didn't know about this email. So we asked the IT department who owns this email address, and they sent us or forwarded us to the accounting department. So we get to the accounting department and ask them what they're doing with this confirmation email that they get for every order. And it took a while for them to realize what we want from them, but then they found out like, oh yeah, this auto confirmation email, we don't need it. We just delete that every time we receive it. So in general, that means that like customers are waiting a second for an email to be sent that then gets deleted automatically. So we could just drop that, sending that email. And another thing we did is obviously we are capturing money from a payment gateway. If you pay with a PayPal, credit card, whatever you do, usually you authenticate, and then in the payment step and the checkout, we capture the money, which actually transfers the money. It changes the owner of the money from from our customers to us, and that can take a while. So when we read all of these things that are happening, besides the first one, there is something in common, and that's our customers are waiting for all these things. But honestly, most of the things our customers don't know that this happens at all, and they don't care about this. I would say they might know about the capturing money because they might get a push notification that someone transferred money, or they know about the email because they get the auto confirmation email or they expect that, but they are not expecting, they don't care and don't know about tracking. They don't care about us sending emails via SMTP or how do we actually transfer the money to us. So they don't know about these things and don't care. And I would even go as far as saying that if the customers in the e-commerce systems don't know that these things are happening and they don't care about this, then they should not wait for these things to happen. So basically what we do is we wanted to do stuff just later. And there is two stories I want to tell you. One is about emails. We were sending out 2 emails in the entire process of someone ordering stuff in this system. The first email is an order confirmation email that you get, just confirming that you placed an order and what you bought and like the delivery address and all of these details. And the second email you get when we send out the parcel. When that is given to the logistics partner, to DHL or someone else, then we send you an email that the order that you placed is being shipped now. And the interesting thing is when we had an outage of sending emails, no one was calling, none of the customers were calling the customer care department because they had not received an order confirmation email. No one cared about the order confirmation email, but people were calling if they bought something yesterday or the day before yesterday and they have not received a parcel dispatch notification. Then they were calling and asking for the status of their order. So that's actually the email that is important. The other email, just sending the order confirmation email, no one bats an eye. And the other thing is about capturing money. We capture money in the checkout process, like when you hit this buy now button, we capture the money. This takes it's an API call. In our case, we measured it. It can be something between 200 and 500 milliseconds, which is usually okay. But the reality is also, usually when you do these online payment things, what you get is in the authorization step, the customer authorizes you to capture a certain amount of money. And what you get in exchange as the e-commerce system is you get a token. And you can use that token against an API call to actually capture the money. And you can do this as long as the authorization token is valid. And that's not only valid for a few minutes or hours. Those tokens are usually valid for multiple days, sometimes even weeks. So you can capture the money at any point later. The only advice is capture the money before you send out the parcel. Otherwise, you might not get your money. So for us, we decided to do this asynchronously. So we wanted to go to a more asynchronous kind of architecture. So we opted to set up RabbitMQ. The general idea, let's say architectural idea, was to not do the stuff now, but whenever there's an order being placed, we create a message about this order being placed with all the details and move that into RabbitMQ and then have RabbitMQ acting as a queue service and some services behind that actually process the stuff, like sending out tracking data, capturing money, sending out emails, all these things. Because the customer do not need to wait for these things. One disclaimer, if you have something that works for you, stick with it. If you have Redis, for example, Redis has a PubSub queue that you could use. If you have any other system, if you're already in AWS, find a hosted system. Let's say we had some fun with setting up RabbitMQ. In the end, it's a pretty nice system and it scales super easily. You can always just start a new instance and point it towards the cluster and it will magically just work. But we also had 1 or 2 outages thanks to us not knowing enough about RabbitMQ. So that's this point. Okay, has anyone ever worked with RabbitMQ? Just raise your hands if you have. Okay, few, nice. You would probably also say this is a highly simplified view of what RabbitMQ actually does. If you don't know how RabbitMQ works, it's not too complicated. You have a producer, that's the P here, which is basically your e-commerce system or whatever. You have something that produces a message and sends that to RabbitMQ. And in RabbitMQ, you have an exchange. That's this blue box here, blue box with the X inside. That's the exchange that takes the message. And when the exchange has the message, your producer can go on and do other stuff. And the exchange then can be configured. You can decide, can give it rules. And based on rules, the exchange will forward those messages to queues, which is the red things here. And then RabbitMQ will push those messages towards the consumer. And in our example, we want to concentrate on the consuming side. That's the C here. So what we wanted to do is we wanted to build an asynchronous consumer on the other side, just like doing the work in the e-commerce system. Sending the message to RabbitMQ was not really too hard. That's pretty easy. And yeah, so we wanted to do this. So our consumer has a few things that we need to do. First of all, we need to consume messages from RabbitMQ, obviously, because we decided for that. And we decided to, as a first, let's say, playground, or just to play with it, migrate the tracking service. So where we send tracking data to our catalog service, that was the first thing we decided to migrate, because that would be super easy. Because on the one side, we would just need to read the message from RabbitMQ that there is a new order placed. And on the other side, we just send HTTP requests to that service. That's basically it. We wanted this consumer to be non-blocking and async. There is multiple problems or multiple reasons why we wanted to have this. So first of all, before that, we had like 10 application servers. That was 10 PHP FPM servers that were serving all the requests, and they were waiting in parallel. And whenever the load balancer found that one of those servers was full of requests, it just routed requests to other servers. So basically, this was the load balancing also for the waiting time. And in this case, we don't wanted to set up a bunch of servers. We just wanted to have it pretty small and have just one consumer that consumes the message. The other thing is we wanted to host this on a very small instance. And the idea of we just receive a message from RabbitMQ, create an HTTP request, and send it and wait is that this process will spend its time waiting 95%. And just 5% doing actually something. If we would spawn multiple processes, which would not be a problem, every one of those PHP processes will eat up at least 30 to 40 megabytes of RAM. So if we spawn 10 of them to be able to wait in parallel, this would already allocate like 400 megabytes of RAM, so we could not go with cheap and smaller instances. So this is also one of the reasons why we thought like it would be nice if just one process could do the entire work. Yes, and we wanted the consumer to be written in PHP. There were some people telling like we could do other languages like Go, Rust, Node.js, whatever, but we wanted this to be done in PHP. And the question is obviously why we want to do this in PHP. Now, if you fire up your favorite search engine and you search for asynchronous software development, PHP might not even show up. You will probably see a lot of Node.js examples, probably something around Java. Go maybe, maybe even Rust async, but probably not PHP. So if you go to Stack Overflow and ask the nice people over there that you want to do some asynchronous PHP, and if they can help you, you probably get this response. Why don't you just use Node.js? So really, there is a like, you can answer this question, right? So PHP has the native functionality to write asynchronous code. This is there since PHP 4.3. With PHP 4.3 came the option to set streams and sockets non-blocking. And it also has the mapper to stream select, which is basically all you need to build your event loop. Granted, there is no promises in PHP native. There is no own event loop implementation. There is no async and await keywords. but there are libraries that bring all of this for you. They bring event loops and stuff. And these libraries also work on core PHP without any extensions. If you're building a service that is heavy concurrently, like you're processing a lot of messages from RabbitMQ or a lot of HTTP requests, then it might be helpful to install Xevent or XUV, so you get a high-performance event loop. But otherwise, it will just work on stream select and will work pretty fine. And the other thing, why PHP is, we already understand it. That's another question. That's another thing. I mean, if we would start doing something in Go, in Rust, in Node.js, whatever, it's not only about the language that no one was familiar from us, it's also about the problem that we don't know the ecosystem. For PHP, we know that our dependency, we can install them using Composer. We know that we can write the test with PHP unit. We have PHP stand to do static analysis. We have all these things at hand. Our local development setup, the IDE that you're using, all speaks PHP. Like everything is there and you know this. So it was pretty easy to say, just let's try and stick with PHP. Disclaimer, it's still a good idea to learn a new language every now and then, especially all this asynchronous stuff and promises. I got exposed to that when doing front-end JavaScript in the browser. Then you suddenly see that a function that does not necessarily need to block, and it might just give you a promise. Then it's your turn to handle this promise, and you have a native event loop. So if you learn new programming languages every now and then, you get exposed to new programming paradigms and to new architectures and new IDs, which is a good thing, I'd say. And one of these libraries that come with promises and event loops and everything is ReactPHP, which I want to introduce you today a bit. So ReactPHP supports PHP back to 5.3. Is anyone still working on PHP 5? Oh, sorry. But even then, like you can use ReactPHP. So ReactPHP brings an event loop. ReactPHP brings a lightweight implementation of the common.js promise A pattern. So you get promises with ReactPHP. And it brings you event-driven, readable, and writable non-blocking I/O. And it also brings you async and await, not as keywords, because that would be a programming language thing, but as functions. So you can wrap your function calls in async and await function and gives it callbacks, and you have the same thing as you would see with Node.js and other languages that have async and await as keywords. Okay, and to introduce you a bit into ReactPHP, I want to build a worker. The worker on the right side of the consumer that consumes message from RabbitMQ and sends HTTP request. So to get this straight, what we're going to do is we're going to on the one side see RabbitMQ. We're going to send HTTP requests to on the other side, and we're also going to observe the payload, like what we're actually sending over the wire. Okay. See if this works. That looks good. Nice. Okay. So we're gonna have there is a few things you need to install. So you would need Bunny. Bunny is the asynchronous RabbitMQ client that you can use. Like Bunny has also a synchronous interface and an asynchronous interface. That's also why we choose Bunny, because we could use the same library in the producer, which we did not want to completely rework, and also in the consuming side. So it was pretty easy to check this out. And then we would need React HTTP, which is the HTTP browser for ReactPHP. The React async, we don't necessarily need that. You only need that if you want to use the async and the await keywords functions. Otherwise, you're fine with just Bunny and HTTP. And Bunny and HTTP, they depend then on the event loop and on promises and all these ReactPHP libraries. By the way, because you see it here, the namespace is React and not ReactPHP. That's just React and ReactPHP, React, the JavaScript framework from Facebook, and ReactPHP, they don't have anything in common besides the name. And actually, as I heard from the author of ReactPHP, ReactPHP was there first, had the name React, but then Facebook launched their React.js framework, and so they realized we don't stand a chance against this. So the ReactPHP framework renamed to ReactPHP. Okay. Yeah, that's the composer.json. So if you install that, then you have your dependencies in the vendor directory, and you can start using Bunny and HTTP. And we're gonna just write some code now. So I prepared this so that we have the autoload file included. And the first thing we want to do is we need to connect to RabbitMQ on the one side. For that, we need a client. And there is 2 clients. There is, let me make this a bit smaller. Can you still read it in the back? Is it good? Good, okay. Okay, so we need a new, let's make this again, new client. There is 2 clients, or there is 3 clients actually, but you can see there is the first one is just the Bunny client in the Bunny namespace. That's the synchronous client. We don't want that. We want the other one. That's the in the Bunny async namespace. That's the asynchronous client that uses the ReactPHP event loop. So that's exactly the one we want. If you just install the dependency, it brings like everything. So you have the synchronous and the asynchronous client. We want that one. So we don't need to do anything here. It fetches the event loop itself. And then on the other side, we need to talk PHP, HTTP. So we need a browser. And that's this one, the React HTTP browser. The React HTTP browser has a nice interface because you can just call get and post and stuff and give it arguments and it will magically do the stuff. We see how to use this in a second. So now that we have this, let's actually connect to RabbitMQ. So we have the RabbitMQ client, the asynchronous client. So that's client. And that has a lot of functions, but we want the connect function. You can see in the description, the asynchronous client connects to the MQP server, and at the bottom you see it returns a promise, which means that it does not actually connect now to the to RabbitMQ, but it will set up the connection and everything, and then return a promise that sooner or later it will have the connection or not, and then it's our point to handle this. So what you usually see then in ReactPHP applications when you get a promise is you see a lot of then calls. So the connect function returns a promise. So what we're going to do on the promise is we call the then function. And the then function gets callables from us. The first one is for fulfilled. So when the promise got resolved in a successful way. So in this case, it means the connection is established. And the second callable is when the promise got rejected. That's when, whatever reason, the connection to RabbitMQ could not be established. And then usually you get, in the rejection handler, you usually get an exception that describes what was going on. So you can handle this. In this case, I don't care about it not connecting. I hope that it just works. And we just give it a function for the successful case. And this function retrieves the client again. And then on the client, like once the connection is established, like the TCP/IP connection to RabbitMQ is established, we get the client back in this callback. And what we need to do in RabbitMQ, because it speaks the AMQP protocol, we need to establish a communication channel with RabbitMQ. So we can just call the channel function on that client, on the connected client now. So that gets channel get first available channel ID, and it returns also a promise. You can see there is a return channel or promise interface. That's just because the channel here is tagged to be the abstract client, because the synchronous and the asynchronous client share an abstract implementation for some stuff. So the channel function serves both. So in this case, I know we do get a promise because we use the asynchronous client. So we can just call this. And what we need to do is we need to do something with the promise that we get. So in this case, we can just return the promise and do promise chaining, which means that by returning the promise in the callback, we have another promise here that we can call the then function on. And this will be called when the channel is established. So let's implement the function. And that function gets the channel. Okay. So now we have the channel. So after the connection is done and the channel is established, this callback will be executed by the event loop. Now we can do stuff with the channel, and on the channel we can finally start consuming messages. That's what we wanted to do in the first place. So that would be channel, and then channel has a consume function. And this consume function, you give it a callable. That is the function that should be called for every message that RabbitMQ pushes to the worker. And the second argument is the queue name. And then we have like consumer tag, no local, no ACK, exclusive, all these stuff. We don't need this all at this point in time. And the channel consume function also gives you back a promise. That is when it starts consuming. We don't need to do anything on this now. We don't need to handle that. But you could possibly also handle the case where for whatever reason, I don't know, that could happen. You have a connection and channel, but you can't consume. Okay, so in this case, let's consume. And the callable that we give it has the following function arguments. The first thing we get is the message, which is a binary message. The second is the channel again, like the channel on which we are listening for messages. And we also do get the client. And so this function, or the function body, is empty, but this function will be called for every message that comes from RabbitMQ. So the first thing we're going to do is we need to check on the payload. I said that in the introduction to the demo, we have some payload that's going over the wire. So let's have a look what the payload actually is that we are sending. And oops. Payload JSON, this one. This is what we are sending over the wire. So this is what the producer, or in our case, the e-commerce system, created. This is just the JSON LD. So if you know schema.org, schema.org has a lot of predefined schemas for JSON and for how JSONs could be structured. So in our case, we found an order there. And the only thing you do is you create a JSON and you write this add context and the schema.org and then the type at schema.org. So if you go to schema.org/order, you'll find the definition for an order from schema.org. And that order has the order type has different things. One thing it, for example, has is it has a customer, and a customer can be of different types. So one of the types can be type person. It can also be type company. And then if you tag this customer as a type person, it's defined to have like a name and an email address and stuff like this. There's more. There's like delivery address, invoice address, all these things. We don't need this for this example, but just to get the spirit. And then we have ordered items, which is the items in the order, which is an array. And this can also be of different types, but our needs were fitted with the order item type. So we have a type order item, and that has an order item number and an order item quantity. And then you can be more specific and say the ordered item of the order item is of type product, and you can specify names and prices and all these things. The good thing why we choose schema.org or the JSON LD format is, first of all, it's a JSON that's pretty easily producible. In PHP, it's easily producible. We could also give this to an API endpoint and have JavaScript work with that pretty easily. And the other thing is schema.org gives you JSON LD schemas that you can use to validate those files. So you can actually expose this via an API. And once you get such a JSON file, you can validate against a predefined schema. Okay, so now that we know it's a JSON, we can just say like the order is JSON decode, and we need the message, and the message has multiple fields. In this case, we just need the content. The content is just the JSON payload. that we're sending over the wire. There is other things you can set headers with your messages that you're sending, and then react on those headers either in RabbitMQ in the exchange or in the client. So in the client, you can also retrieve the headers and check for these things, check what's going on. So one thing, for example, is in the header, if you requeue a message, or if a message will be delivered and the worker doesn't acknowledge the message, it gets back to RabbitMQ, and RabbitMQ delivers to another worker. Then you get this information in the header, so you can see how long the message has been lying around in the queue, how long it took to actually get delivered to the worker, how often it was tried to deliver to workers, stuff like this. You can all see this from the header. So you could do a logging about this, and then you could see nice graphs that your message are being redelivered for reasons. Okay, now we have the order. The HTTP service or the tracking service wants us to send HTTP request. So we're going to iterate over the ordered item, I think it was, as the item. And then we're going to send HTTP request. For that, we need the browser. So we need to pass in the browser here. Something's wrong. I think here. Okay. Now we can use the browser to send a request. So you can see the interface of the browser is just the HTTP method. So get, put, post, head, patch, delete, and so on and so on. In our case, it's just post. And the post method wants the URL from us and an array of headers in the body. In our case, the URL would be, doesn't really care, just something. We do not have any headers. There's no headers to be sent in that case. And but we do need to send a body. In our case, the body is an HTTP query that they want in the body. And that is an array content. And the contents of the string that they want to have is just the SKU, which in this case is item item number, and they need the amount. And that's basically it. That's what they need. And this is also where you can start seeing why this was a problem when this was in the synchronous interface in the shop system itself. So most of the tracking services that we were talking to actually had one endpoint where we were just sending the entire order, and then they had the order with order information, numbers, and shipping costs, and articles, line items, all these things. They had everything in one API request. And usually the API were reacting between 100 and 200 milliseconds, so that was okay. In this case, for the catalog service, they had a different API. And that API was that we needed to send them an API call just with the SKU and the amount, nothing else, but per line item, not one for the entire request. Now, and the API was slow. So they had sometimes 300 to 500 milliseconds round trip times. So when you as a customer are buying like 10 different items with us, and we're sending one request after the other, that sums up to 3 to 5 seconds, which is a problem. The more people buy, like the longer they wait for these things to happen, which is not what we wanted to have. Okay, but this will still not work. The problem still left here is with this post function. The post function, there's two things. The post function also returns a promise. So the post function will not just execute and do the HTTP request, but once it has a HTTP response, it will resolve a promise that it gives us here. Now, one thing we need to do with RabbitMQ is we need to acknowledge the message. So we need to tell RabbitMQ that the worker is done doing whatever has to be done, that RabbitMQ can forget about the message, and everything is okay. Now, we could just do this without waiting for those requests. But I mentioned this is a asynchronous interface. So when we actually call the browser post function, this will not send the HTTP request and wait for the response. What instead it will do is the browser post function will open a socket, mark it as non-blocking, and will register the socket with the event loop. And whenever the socket becomes writable, then it will go on and start writing. And that's also the moment when it will return the promise to us. So if we just go over this loop really tight here, this will just create whatever. If you have 10 line items, it will just create 10 open sockets, and we'll start waiting for them. It will not do anything at this point in time. So we should not acknowledge the message to RabbitMQ because we have not yet sent out the messages. And as we can see, the post gives us a promise. Now what we need to do is we would need to acknowledge the message to RabbitMQ when all those post requests are done. So we cannot just write a then. Usually we would just say, we call the post function, post gives us a promise. So we just call then, and whenever that's done, we just acknowledge the message. We can't do this here because we need to wait for all of these promises. So what we can do instead is we can collect those promises and then wait for all of them. So after the loop, there is a all function that comes with ReactPHP, and the all function returns us a new promise that will resolve only when all the items, all the promises that we gave it have resolved. Then this will resolve, and then we finally know that all the promises have resolved. In our case, this will tell us that all the HTTP requests are done. So this is finally, let's say, the blocker to wait on this. And this gives some arguments, but we don't need any of them. But what we need is, we need the message and we need the channel to acknowledge the message on the channel. So we're gonna use message and channel. And then we can call the channel has a acknowledge function. Yeah, this one. This acknowledges the message that we gave it. And this will basically then send a acknowledge to RabbitMQ, telling it that we have processed the message, whatever we need to do with it. And that is basically a fully functioning worker, fingers crossed, because it's not handling any errors. But technically, it is working. Okay, so let's try and get this back. Okay, so for the one following on the slide, so if you want to look at this later, I have the fully working example that we just created on the 2 slides, but please don't. You're gonna see why. This function, so this is like the first part is just creating the connection, establishing the channel, and then starting to consume messages. And the consume function gets the app variable, which is on the next slide. This actually works under the condition that RabbitMQ is listening on the default port on the local host, because that's the default argument values for the connect function. So if you call that, it will just magically start working. If you have your RabbitMQ set up in a Docker container on some other port, then it will not work anymore. Also, what you can see here, there is no error handling. So if it breaks, you keep both pieces. So don't break it. So not necessarily meant for production usage. And the other thing you can see here, or if I forgot in the live coding, is this part here in the end, the loop run. Actually, what's happening from the control flow is we have the client, then call the connect. Connect will just open the socket, mark it as non-blocking, and then register it with the event loop to wait for it to be writable. And that's all that, then it returns a promise. That's all that happens. Nothing else happens. Nothing of this is happening. No client channel function, nothing of this, like all of this is not happening. It jumps straight from the connect, following this then function on the promise to here. and then you need to start the event loop. And then the event loop will start to iterate over those over all the sockets that libraries gave it. That's the one thing. The other thing, the second slide is what we just created, is this the function. The function gets the message, the client, the channel, the client. We need the browser. We chase and decode. We collect our promises, put in post requests, and then when all those requests have fully filled, we acknowledge the message towards RabbitMQ. You can also see here there's a lot of stuff not being handled. Like this is the absolute happy path. So if the JSON is not correct, we're going to have a problem. If there is, for whatever reason, no order items, we're going to wait on empty promise array. I actually don't know what that will do. We could find out and try. Also, another thing is the browser post will, like, in the end, send the post request or multiple post requests and give us promises for all of these, and then they will resolve. But it could obviously happen that, like, if you have 10 line items and we're going to send out 10 post requests, only 9 of them get a 200 OK status code, and one of the other requests will just fail. So you have 9 resolved promises and 1 rejected promise. And as you can see, we don't handle that case. We just handle the case where all the promises are resolved. So in that case, the message will never be acknowledged with RabbitMQ. So RabbitMQ, after a defined timeout, will just requeue the message and redeliver to another worker, which might suffer the same problem. So you'll send a lot of tracking data that doesn't really exist. So yeah, you need to keep all of this in mind if you do these kind of things. Not just if you get a promise, you need to actually handle the case that it could be rejected, which is a reality. Okay, so even if you copy paste this from the slides, technically this will work, but please don't deploy this to production or add error handling and handle all those possibly rejected promises. Okay, but there's one more thing that I want to show you before closing this off, is how fast can this actually be? How much messages can we actually handle that way? So for that, I prepared another demo. I hope that I get it working. Oh, let's see. So, sorry, it's not dark mode. This is the RabbitMQ management interface. So when you start RabbitMQ, it not necessarily comes with a management interface, but there's there is a Docker container containing the management interface. There's one without. So this is the one with, because I want to actually see what's going on. So in this case, we see there is like RabbitMQ overall has here 3 million messages in queues. There is no messages going in or out. And in this case, we want to go to the queues and streams. And then we can see there is a hello queue, and this one hello queue is running, as in RabbitMQ is taking care of it. And there is 3 million messages ready in this queue. So when we go to the queue, we can see these nice 2 graphs. Now it's better. We can see these 2 graphs. The one is the number of queued messages in this queue, and then the message rates in the last minute, what's going on there. And I have a small script, not this one because it's sending data and I have everything turned off, but this one. This does nothing really specific, but okay. This does nothing really specific, but like we've seen all of this on the slides and in the live demo, this is connecting to RabbitMQ localhost. When it has the connection, it establishes a channel, and then it starts consuming messages. And the only thing that worker is doing is whenever it has the message, it instantly acknowledges the message towards RabbitMQ, telling it that it's good and done. And we're going to execute the script, and then we're going to look into the management interface and going to see how many messages RabbitMQ and PHP is processing. And one thing I want to tell you also, like before we start the script, is this all is still single-threaded and no multiprocessing, no multi-threading. This is one thread, one process, just doing asynchronous PHP. So we'll start the consumer. It looks like it's not crashing. And we can see here there should be some numbers in a few seconds once it started consuming messages. Oh yeah, there it is. So we can see that it starts with 84,000. Yeah, and it clocks in at 99,000 messages per second that this consumer is just acknowledging. It's not doing anything else, so it's not sending out HTTP requests at this point in time. But you can see like nearly 100,000 messages per second for a single-threaded, single-core process, which I think is pretty awesome. And this is happening on this laptop, so it's not on some remote server. So the 3 million messages have been processed in 20 seconds, which is pretty nice. Okay. Wrong. Okay. Yeah, that's all I have, folks. There is, if you're interested in this, there is ReactPHP.org, which is the webpage of the framework. The framework itself is everything hosted in GitHub. ReactPHP.org has a pretty good documentation about the stuff that is going on, about how things are working. There is a lot of ReactPHP tutorials. If you look on YouTube, there is a few channels that have courses about how to build stuff, which go as far as using WebSockets to build a chat system using ReactPHP. You can bake this if you need persistency for ReactPHP-based WebSocket chat service. This uses Redis in the background with multiple channels, so you have multiple rooms in your chat system and stuff like this. It's actually pretty amazing what you can do. Then there is a talk that's called Pushing the Limits of PHP from Christian Lück. He's the author or co-author and maintainer of ReactPHP. And if you want to get in touch with me, you can find my blog on dotbox.org. There is also the slides for this presentation. And yeah, that's it. Oh, there's one more thing. If you're hooked with ReactPHP, I have ReactPHP stickers. You can take one, and you can also have a look and cuddle with this one. This is a prototype, so this is the first one in existence. Yeah, and that's it, folks. Thank you very much.
フローリアン様、発表ありがとうございました。質疑応答の時間に移らせていただきたいと思います。質疑応答ある方いらっしゃれば挙手をお願いいたします。
Thank you for your talk. I am a very enthusiast as async programming in a PHP, so I use ReactPHP all day. So I have some problem. I could be write programming async with PHP. So, but my teammate is too difficult because very different paradigm in all those nowadays PHP and async PHP. Example, event loop, no event loop in normally PHP.
Yep.
So I think I find some training path or something like nice. I want to teach or train my teammate using event loop, and I want convert old code, no event loop, and now event loop code. So we want to find nice migration way in all the mud PHP, fast easy and other way. So do you have something nice migration path, or do you have an opinion? We must make a scratch.
Yeah, probably. But so the migration way that we were using is we tried to find the smallest part of the problem. Like in the big picture, there was a lot of stuff going on that people were waiting for. But we decided to not rewrite everything, but start small by just creating this small worker. And you've seen on the slides, like even if you add error handling to this code and catch the rejection paths of promises, even then it's not too much code. that you write. So it's really a small bunch of code that you can deploy. And so that was our idea back then, just not rewrite everything from scratch, because that will probably fail horribly. But just like look for the small, really tiny part that we can rip out of the system and translate to a new paradigm. And that's where we ended up with this tracking service. Later on, we migrated also the capturing of money and sending SMTP requests and all the other stuff. But I would advise to try to find something really tiny